Thank you all for joining. And we'll give the floor to Albert to introduce the session and then pass to Ignacio. Okay.
So I hope this is all visible. Thank you for joining, and I will go to my first slide. It's the smart case, of course, to do this. So thank you for joining here. We're here in the series of RIA Showcase webinars, and as Open Continuum coordinator, I invite you to join us, and I will explain a bit how this is working, because there's two CSAs collaborating. Open Continuum is working on the supply side of the Continuum landscape, closely working with EUCEI, who's focusing on the demand side of the landscape. And together we have our own CSA, but we have joint task forces to support all the projects. And in this, the task forces, we also have the support for all the RIAs, and we're organizing this series of RIA showcases today. I just jump in quickly on the task forces, and I invite all participants, if not joining and participating actively in these task forces yet, to consider, to contribute and learn. We have a first task force led by Insight that's focused on liaison with EU initiatives and the industry. I mean, we're all in need of a consortium or a community to build, and Insight is leading the task force to help you do this. We have Eclipse leading Task Force 2 on open source. It's not just Eclipse, but Eclipse is the lead in this. And so we have a close collaboration with other open source entities in Europe. Evident, or for some people still known as Atos, is leading Joint Task Force 3 on a joint taxonomy, common taxonomy, and a joint reference architecture. Bear in mind, 28th of May, there's a presentation in Helsinki provided by Open Continuum on standardization for the Continuum, the CloudEdgeIoT Continuum. Here's a contribution from some of the MetaOS projects. Also FlUIDOS is going to join there. But it's interesting for all of us to look into this standardization. We have two task forces from the demand side, led by Blue Specs on the open calls and the ecosystem engagement from the demand side. And we have IDC doing markets and sectors research and analytics. And today is hosted by Joint Task Force 6, which is led by Martel and sometimes I'm missing the names here, but Alexia is representing this, and Katarina may join as well. So the Task Force 6 community building, this is the largest community task force we have at the moment. We have the monthly digest. We have the website with all the events that are taking place. So look at the website if you're looking for events to promote your project. On the other hand, if you have something organized or in mind to promote your project, please let us know so we can support your disseminating and communication activities in this. So today we're here on the Meta Operating System Innovation Landscape, organized by aerOS and FlUIDOS. And we already had two, and you see there's a few more in line. So next week, in 2 weeks, we'll have the open cloud computing webinar, and then there's more on Swarm and open source coming. But for today, we'll focus on the MetaOS projects, and I'll leave the floor to the participating projects. Thank you for the introduction time, Alexia.
Thank you, Albert. I think Ignacio takes the floor now.
Yes. Okay. I will take the floor. Let me please share my screen. Please let me know if you can see properly the presentation.
Yes, we can see it.
Yep. Okay. Thank you very much. So, thank you, everybody. Welcome to this workshop where we will try to give an overall view of what's our perspective on how we can, innovate the CloudEdgeIoT landscape. We are a bunch of projects that were funded, and the goal Cluster 4, Data 0105, that was published in 2021. And we have been executing our projects for a while now. Actually, we are at the verge of our midterm review that will take place actually next week. So I would say that we are now in a good position to expose what we believe is, how the global field is and how we are innovating on it. Also, where we are applying our innovations, in which sectors that we might consider strategic for certain reasons, and also working together with, for us, I think it's very relevant, and I would like this session to also be conveyed to transmit this message that we are trying to, although each of us has its own goals and perspectives, we have tried to work together towards common goals. So in this regard, we, meaning the global cluster, all of us here, Nemo, Nebulos, Nefel, ICOS, FlUIDOS, and aerOS, we have, thanks to the coordination of the different task forces that Albert has introduced, we have met in several occasions, both physically and virtually, trying to come with brainstorming of ideas, how we are approaching different aspects in the project differently from one point or another, trying to come with some joint ideas and conclusions. In particular, you can see here that this started as soon as January 2023, so more than 1 year ago already. We met in Toulouse in a workshop organized that's for 1 and 3, and architecture, and also by Eclipse in Toulouse, basically, in which we were around it together to showcase what the technologies that we were trying to use and what we saw globally in the field. By that time, most projects had already delivered a state-of-the-art document basing on what they saw in the field. And these are some of the conclusions we reached that, to be honest, have helped us fuel and move towards and have this how we are approaching basically the innovation in the continuum. We identified that there was at that time, and basically still is, a lack of coverage within the range of computing devices in the continuum. While in the more cloud part or in the more centralized part, things are covered well. We have realized that when you get closer to the IoT edge side, then the coverage of global global tools with good documentation or a clear reference was missing. So there was clearly a gap that we would try to cover, basically. So also we are reached to the conclusion that there was no open source end-to-end service pipelines that will help us clearly abstract the complexity of the underlying infrastructure that might have different computing architectures, different data connections, different API configurations, etc. So we didn't have that specific reference. There were some tools, but not exactly a reference. So there was another gap that we could cover. Could try to provide a reference on how to cover it from a European perspective. Also, interoperability issues were clear in terms of data, network, technologies, connectivity, etc. So we realized that in both the state-of-the-art of the different projects. Also, although privacy and security are very hot topics in research and innovation, we realize that also they are not tackled homogeneously. Different projects and different verticals and use cases have their different concerns and bottlenecks with regards to cybersecurity and privacy. Therefore, we needed to tackle this homogeneously, or we at least realized the reality, right? And that all stages of the life cycle of applications were not covered the same way. Since day 0, day 1 operations might be well covered, and then maintenance of services, at least from the research perspective, was not so good. That's the point. Therefore, we proceeded to that. And of course, basically, we lacked the formal structure and even definition of what the continuum is, what it can do, etc. So we identified since the beginning that this was one of the points that we could focus on, basically formalizing and making it properly defined. Advancing on that, and thanks also for the coordination by the task forces, Task Force 3, of EUCloudEdgeIoT, we focus on mid 2023, more or less towards autumn 2023, on providing this formalization that was missing. That was basically coming together, brainstorm, have several documents working together, agree on creating groups for defining the terminology, the taxonomy. Because it's well known that for tackling a complex issue, first you need to have a common language to speak of it. And this should start with us that are coordinators, technical coordinators, innovation leaders, technical responsibles in the projects funded under this topic, to come to terms that we believe mean the same. So we started with just 2 workshops defining with what those terms were, which those were, where they were belonging to in terms of the building blocks that we tried to define. And we basically place them in the proper spots and try to come to an agreement to where they are fitting or they are not fitting. After several rounds of iterations, checking, excluding, including, identifying terms that basically meant the same and that were used and are used differently across projects, we came to these agreements, and we published the taxonomy of the building blocks and the terminology that we meant. And this was for me quite an achievement, because this was putting 6 projects working together in the same table that underlying they have 20 plus partners per project, and different sensibilities, different feelings, different approaches from different backgrounds come together. And we were able to provide and to make this exercise. Also, when that was ongoing, in parallel, we tried to not only keep this internal, like discussing among us how we should come to this common point of agreement, but also exposing it to the community, right? Basically, thanks to the organization by different task forces, here not only Task Force 3, but others such as 4, 1, 2, 5, 7 webinars were organized, both specifically focused on technologies, like how the technologies fit the demand skills and the markets, or how we might innovate this landscape, or like this very webinar, for instance. And also we all met together in a very large scale event in Brussels in May 2023, where we all were present. We were able to share our thoughts, and we also shared this with many other projects coming from different clusters. So we were, dozens of projects coming with related topics: cloud, swarm, AI, RISC-V, architectures. So we were able to understand and to confirm that our impressions were correct, our assumptions were in the right direction, and that what we were doing was basically what the global field and the global researchers across Europe were also working into. Therefore, this reinforced and reassured us in our line of work. At least this is what I can relate from aerOS perspective, but I am pretty convinced that my colleagues here from other projects will also share the same view. As I was saying, we didn't stop just only on technical exposure of what we were doing. We also brought this knowledge into what we are applying in our different projects. We all have specific use cases, what we are working in different sectors like agriculture, energy, manufacturing and transportation, health. And thanks to the coordination by EUCloudEdgeIoT, we had the opportunity to bring and perform pitches and explanation of how we are bringing our technologies to these use cases, how these can help them, which for me, it's a very good first step towards further large-scale future adoption of our technology. If we want us to actually create a standard, to actually deliver a technology that can be adopted, then we must start since the beginning permeating the message that it's useful already since the very low TRL research stages for different sectors that are considered strategic for the European Commission. So that's what we also did in the intention with the underlying perspective that is the webinar today, is innovate cloud edge IoT landscape applying to these sectors. Also later, one of our most collaboration work focused on the architecture standardization of the Continuum. There has been this continuous effort led by Atos, evident now that they are putting us together, trying to moving forward are advancing a step beyond of the taxonomy and the building blocks, but creating internally in the building blocks specific components, very well, much clearly in detail described, in which our different components of the projects map. So we created these blocks with these 8 different fields or areas of applications of the components that would form an architecture of the continuum, just security and privacy, research management, trust and reputation, data management, monitoring observability, artificial intelligence, and orchestration. Each of these blocks, a working group was formed, and different people and representatives from projects belonged to these working groups. Several responsibles were assigned, and we have been working, trying to bring the knowledge that we are gaining in the research in our projects in order to make more formal definitions of these building blocks and the components that form them, without digging too deep into what exact open source technologies should be leveraged. This will come later in our roadmap. But we try to clearly define what must be covered by each point, what continuum deployment to be considered as such should incorporate at least. The idea is try to move this forward towards a pre-normative standardization action at some point in the future, and we are collaborating with IOTI and with some SDOs such as ISO, IEC. We are, with the help of Trialog, which leads that aspect in the CSA, try to move forward this initiative. We are already generating pre-documents. We are actually ongoing activity of consolidating all projects' feedback. So we believe that in the third and fourth trimester of the year of 2024, we will be able to have this a reality made, basically. And just to conclude my presentation and to start passing the floor to the representatives of the projects, I would like to make some conclusions that we made up to this point with this evolution and with these activities performed, which is, since the beginning, we realized that there are common ideas shared among projects. This, of course, doesn't come as a surprise because we actually targeted the same topic in the Commission Fund program. Therefore, we were tackling the same goals, but always you have several angles coming. Therefore, we realized that there were certainly common ideas that were shared. Using virtualized and containerized services, all of us, or most of us, are strongly basing our research on the knowledge gained by the cloud native community and cloud native principles in the last few years, but properly translating them to, say, less resourceful range of devices in the continuum. And these, of course, lead us to not be able to avoid the relevance that cloud computing technologies coming mostly from American providers are having in our current world. We're trying to leverage that to have our European technology. Then multi-layer orchestration is a common thing that we have observed, both coming from the virtual objects in FL, from the HLO and LLO and aerOS and other approaches, also departing from the LICO perspective in FlUIDOS from the past. So we are kind of all seeing this multi-layer orchestration perspective. All of this, hopefully, all these sensibilities will be able to come together and to materialize in a single understanding that will become part of this white paper and pre-normative document. Also, we have realized that when creating these building blocks, data management, security, privacy, etc., we realized that there are some areas that are in this gray zone that are not so easy to be cataloged. Therefore, they are technical areas that intertwine and that differentiating their exact extent and scope strongly differs from one use case to the other. So we have realized that this actually exists. For instance, resource orchestration with service orchestration at some point, security, privacy, authentication, protection, non-repudiation, privacy, trust are terms that seem to be clear, but sometimes in practice they are so tight and they so overlap that it's very difficult to keep them separated. Or monitoring and management, where does it start, where does it end, etc. And finally, concluding, what we observed is also a common perspective and conclusion for our project is that AI is being used everywhere. right? Both internally in orchestrating the workloads in a continuum, how you organize it, how it's exposed and how it's seeable, how it's discoverable, and also how it enables the applications and the vertical services to provide specific functionalities to, agriculture, transport, health, buildings, energy, or whichever sector that can clearly leverage our abstraction of the resources underlying to provide these advanced neural networks and other kind of AI models for specific functionalities. So all in all, we have been working together for more than 1 year now, and we believe there's much more to come later. I hope you will enjoy and you will learn something in the workshop today. And I also hope that we will have also a nice workshop next week and Wednesday in Brussels, all together putting this in common as well. So that was my introduction. I just now pass the floor again to Alexia for the next speaker, and I will remain here and present later aerOS perspective. Thank you.
Thank you, Ignacio. And now from ICOS project, the first speaker is going to be Savi Masip.
No, I think it will be Francesco who will take the lead on that.
Yeah, okay, then Francesco, the floor is yours.
Thank you, Alexia. Thank you. Actually, thank you for also giving me the opportunity to introduce the technical coordinator of the project, that is Xavi, the professor Xavi Masip, that you just mentioned. Okay, in the meanwhile, let me share my screen. I hope that you can see it. Yeah?
Yes, we can see.
Okay, thank you. So, quickly, I'm from Eviden, from Atos. Atos is still here. Actually, the right name for Eviden is Eviden in Atos business. So, call us Atos Eviden is exactly the same. My name is Francesco Dandia. I'm the Atos is the coordinator of the ICOS action. So, going straight to the point, let me just introduce the project. I will be quick on this, since this information, most of them are shared with our twins projects. So many of those information will be are very well known. The starting from the full name, this is toward the functional continuum operating system. Is a 3 years project, as you know. It's in terms of budget, it's around 11 million, and of course, it's a research and innovation action. And the final expected technological readiness level for the technology that we will deliver is about 5 and 6. We are just in the middle as of the life cycle of the project. As Nacho mentioned before, next week we will be actually everyone in Brussels for this big show organized by the European Commission, where all those projects will be evaluated. And just in the middle, we will have the opportunity to be together in this workshop organized by the European Commission on clear topics that we are facing. So, very good opportunity for collaborating and for closing gap with our colleagues from other projects. So the project involved 20 partners right now. We struggled a bit because in the beginning, because Red Hat left the project, to be honest. But now that we replaced Red Hat with IBM, we are happy. We catch up with the activities, and everything is going frankly well. The project right now has found 5 new little project, so 10 partners overall from the open call, who have been who will bring beside vertical business application additional technologies that will enrich somehow the IQOS ecosystem, and beside that, we plan to fund other 12 new partners who will assess the IQOS technology across relevant and vertical business application in the last phase of the project. In terms of the project goal, like all my colleagues today, the main goal of IQOS is to design, build, and verify a meta operating system for Continuum, for computing Continuum that combines these computational resources, data from cloud edge and IoT. In terms of challenges, we have these 4 challenges: device volatility and heterogeneity, and continuum infrastructure virtualization that will be seen in the next slides, while this optimized service execution and performance together with this monitoring and this being sure that we will use efficiently the resources will be to be provided will be seen in the slide number 4. So let's jump quickly to the number 3, where we present our simplified view of the organization of a cloud edge infrastructure. Then we have cloud providers, we have near edge providers, where here we have hyperscalers that are offering a lot of solution with public, private cloud, and regional computational infrastructure, as well as we have these far edge providers, and in the end of the day, IoT and edge service providers. So IQOS aims to offer a comprehensive solution for managing and optimizing complex business application across providing and managing heterogeneous computational resources and data providers. This includes public and private multi-cloud computing, far edge, near edge, and intelligent devices that are connected through IQOS ecosystem through drivers that we can the IQOS itself is able to manage, and the goal is to ensure an efficient governance of this application. But most of those concepts may already be familiar to you. On the other hand, IQOS wants to be a toolkit used by vertical service providers and operators to manage complex business application with specific requirements, such as location, privacy, security, performance, eco-efficiency, and IoT integration. And at the end of the day, the IQOS characteristics will include a requirement awareness and the optimization of the vertical application topology to a bunch of distributed and heterogeneous resources for getting the maximum in terms of quality of experience and quality of service, ensuring security and privacy, and of course abstracting the infrastructure that we will be using. So we match to have just one open door that will allow to manage those complex infrastructure, having and implementing this proactive governance through this distributed data management. In terms of challenges, I don't want to repeat myself. We through ICOS are abstracting the normal management of application, providing an easy to use tools for those vertical service providers, and somehow this abstraction also is in terms of technologies. So although we are using most of the tools from the Kubernetes ecosystem, we are compatible with several technologies, not only from Kubernetes. So in a certain sense, we can even sell ICOS as a tool that is alleviating the vendor lock-in. So not only being compatible with the Kubernetes, but also with the Docker Swarm, with other tools that will allow to manage also isolated computational resources. In terms of technology and in terms of approach, as mentioned before, we will focus on this optimization of the resource provisioning and the proactive management of resources, and also stressing stressing a lot this security layer and data management layer, and of course leveraging this intelligent layer. So we have this cognitive a layer that will help us to implement all these proactivities and optimization that I mentioned before. Of course, the project is an open source project, totally 100% open source. We are adopting no viral licenses. So our target is Apache 2.0, and of course here you can in icos.project.eu deliverables you can reach out the technical outcomes of the project that can be seen and can be explored, and of course as soon as we will reach a good level of quality in terms of tools, we will be able also to share all the ICOS tools. In any case, if you want already take a look at them, please let us know. We will be very happy to share what we have been developing so far. To end the presentation, I would like to introduce the 4 main use cases that will assess our technologies. The use case for us has been very relevant, included in the project from the very beginning. They participated to the requirement elicitation till the assessment. So although this project has not been a use case driven, the use cases that we have here has been very well took in consideration, and we are working quite closely with them. And on the other hand, what we did from the very beginning is to create a sort of tandem use case, vertical technology provider, and also someone from the core team that will even more facilitate the integration of those technology in ICOS and on the other hand, this will be also useful later on for onboarding the additional partner coming from the open code. So yeah, the first is agriculture use case where we have autonomous robots and we are a field that are far from cities, so we have in terms of bandwidth we don't have much network to rely on, and here we have some of the computational resources are plugged to batteries that are plugged to solar cells, and this will actually create new challenges on connectivities, on management, and also on eco-efficiency, proactive eco-efficiency management. The second is a monitoring of railways, where we need a very low latency, and on the other hand, also in this case, we have low power IoT devices that are far from cities and needs to be managed in the right way, and also in terms of managing network for ensuring that relevant data will reach out cloud infra for further analysis. We have this in-car advanced infotainment that actually Atos is providing as a technology provider, and this is offering to Stellantis for showcases in a car, where we have here as a challenge low latency in terms of interaction, and then we have this multi-user remote rendering solution, and we have collaborative interaction among different peers that will participate to the scenario, to the activities, and here also the challenge is to maintain connected in edge node that is in the car. So we are here plugging an edge node that in the end of the day is nomadic. And finally, we have the smart building use case, where we have homes that needs to through machine learning and through artificial intelligence needs to manage the usage of the electricity, maximizing of course, or minimizing the usage of the electricity, so maximizing also the quality of experience of the end users. And I guess that this is all. Probably I spent 1 minute more than expected. I still think that there are some minutes for open questions.
Thank you, Francesco. So if there are any questions, we have some minutes. You can add them to the chat or maybe raise your hand and you can address Francesco with your questions.
No question. Too boring.
You never know. Maybe.
No.
Okay, thank you in any case. Thank you.
Thank you, Francesco.
Thank you.
You can get back to it if there are questions.
Yeah, indeed.
Okay, so then I guess we are a few minutes early, but we're gonna pass the floor to Fulvio Reiso, talking for FlUIDOS project.
Thank you, Alexia. So welcome, everybody. I'm gonna share my screen. So I would like to give you a brief presentation of the FlUIDOS project and the main results that we achieved so far. So for starting, just a brief introduction on the main idea that we have in FlUIDOS. So we discovered that both in cloud computing and at the IoT and edge, we have many silos in which we cannot share resources. So even if we use a cloud like Amazon or Google or whatever, it's very hard currently to leverage resources in both or multiple cloud at the same time. Like happens when you take my smartphone or your smartphone and you want to use not only the CPU here, but also the CPU that I have on the laptop that I'm currently using right now in this presentation. So, you know, we have, let's say, specific silos in which we cannot allow borrowing resources from a different silos. And this happens surprisingly, not only at the edge and with normal devices like Internet of Things and so on, but also at the cloud computing. So here it is where FlUIDOS comes into play. So we would like to move into from a situation that is where we are right now, in which we have an application. And if we want to deploy an application that is made of multiple components on multiple devices, we have to do that manually. So the user has to say the first component has to go here, the second component has to go there. And this is rigid, inflexible, and in the end, it creates a lot of troubles. The FlUIDOS computing continuum is something different. So you still have your application with multiple components and so on, but you deploy in the FlUIDOS computing continuum, which is like a super virtual cluster that span across multiple clusters or devices or cloud. It doesn't matter, we support several devices and clouds at the same time. And this FlUIDOS continuum does the magic. So from there, all the components are deployed in the proper place dynamically. Not only deployed, but also maintained, updated. So if something bad happens, a component is moved into another location, completely transparency, which is something that we cannot do right now in such an automatic way. So in the end, the FlUIDOS computing continuum defines multiple dynamic and secure virtual spaces, or we call them virtual clusters, that can span across multiple technological domains, because I can have a cluster that spans across my smartphone, my laptop, a server at the edge, a cloud cluster, and so on. And also across administrative boundaries, because not everything might be under my control. So I can borrow resources from somebody else. But the key word that is very important here is transparency. So I don't care whether those are deployed. FlUIDOS does for me. I don't care how they communicate one to the other. FlUIDOS does for me. And I don't care whether I have resources available or not. FlUIDOS will do the magic and find the resources here. So how do we structure our research in our project? We have 5 lines of investigation, or actually 4 lines and 1 final pillar, which is open source. Let's try to briefly present them one by one. The first component is the FlUIDOS node and protocol. So we define a node, which is, let's say, a device, a cluster, a server, which is based on Kubernetes and LICO, which are technologies that are already available in the open source domain. We use, and in some cases, we extend. And then we create, on top of that, our components, which are basically oriented to negotiate and advertise resources and services between different devices. So like my smartphone can say, I have a webcam. If somebody wants to use a webcam and you are allowed, of course, security is very important, you can leverage these resources that I have. And maybe a server can say, I have a GPU or I have a lot of memory. So, you know, you have to advertise your capabilities, and somebody else has to take this information, process it, and possibly use it. So the second component, of course, is the protocol that we use to do that. So it's a very simple protocol in principle, because it doesn't have a lot of phases, but you know, we can retrieve what we call flavors. So we can ask another node, which resources do you have? And we have several kinds of resources. I can export a Kubernetes cluster, I can export VMs, I can export even software as a service, like I can offer you a database. You can just use, you can just consume. I don't care. Okay, you don't care about how it works. I can do that for you. Or I can export the services and sensors because we are supporting IoT as well. Or we can support data. We can export data, just data. So, you know, this kind of information is exported, it goes to the consumer, and the consumer decides what to do. And if it likes what I'm exporting, because, you know, the consumer may ask, like when you go to the market and you want to buy tomatoes, you don't want to buy tomatoes just from one person. Maybe you go around, there are several people offering tomatoes, so you compare prices, you compare quality, and that's the same thing here. So the consumer can compare different offers, and at the end can place a reservation. Says, okay, I like your resources. Okay, a strict negotiation phase follows, and then I can purchase. And this, of course, will be backed by some legal contracts in order to guarantee exactly what you did. So those are the first 2 important components that we are delivering. So the FlUIDOS node, software components, architecture, and so on, and the protocol used to talk one node to another, whatever node it is. The second point here is the Meta orchestrator. The orchestrator is definitely something that is very common in all the MetaOS projects. And also here we are defining this kind of orchestrator, but actually Meta orchestrator, because we support more than one algorithm and more than one tool in order to reserve and orchestrate our resources. You can imagine from what we saw just before that once you negotiate the resources you want to buy, then you create this kind of virtual continuum that spans across multiple nodes. So you and other nodes, and then you have all the resources reserved for you, and then you have to use it. So the Meta orchestrator is something that takes an input under the form of intents. So the user says, okay, I want this service, and this service doesn't have to be more than 20 milliseconds from my customers, and so on. And again, this another kind of magic that deploys all that stuff on the virtual continuum. So in the end, the user doesn't know anything about the virtual continuum, how it's done, how the different components are talking to the other. The FlUIDOS does. Security, of course, is very important here. I don't want to go into the details, but the security has a lot of different issues here. And in this picture, we tried to highlight that there are different phases according to the different workflow that we can imagine when you want to buy, reserve, buy, acquire, and use the resources. So you have to discover who is there. Basically, then you need a proof of identity. You need to acquire resources, you need to use resources, you need to be sure who is on the other side, you need to be sure that the image repository, so the software that you are running is trusted. You have to be sure that nobody is inspecting your workload when it is running on a different domain, so not machines that are on your properties. You have to be sure that you have the proper borders so nobody can attack you, because you have this kind of virtual cluster, and on the cluster you have to enforce the proper protections. You know, many things that are related to security. In this area, we also foresee some, let's say, native security service. So we can even think about buying computing resources from another node, from another cloud provider, and so on, with some security services built in, like threat detection or cloud native cyber deception. This is still part of the architecture, because actually we're buying resources, and with resources we'll also buy software services. So it's like I'm buying some GPUs in foreign domains, and within the GPUs I'm also buying a security service in order to help me to protect my environment. Energy. When you talk about sharing, sharing is something that we know can be actually very efficient. Think, for example, sharing cars, sharing hotels, sharing many things. So, you know, the sharing economy brings us to a better efficiency. And here we have basically two lines of investigations. The first is to share the resources, so create a better and more efficient infrastructure, because I don't have to have a very powerful GPU here. I can leverage a GPU that is provided by somebody else, like it is local. Even if it is not local, it's another domain, but for me, it becomes like it is local thanks to the FlUIDOS continuum. So, you know, the cost of the infrastructure will decrease. And the second line of investigation here is to reduce the carbon footprint in order to leverage, preferably, resources that are more energy aware. So like instead of buying resources in a data center powered by carbon energy, I can buy resources in a data center that is powered from solar energy. Like here, where I'm right now at home, there is a fantastic sun today, so I'm producing a lot of energy. I can really host some job, some workloads from my neighbors here, because I'm just running on solar power. So energy is definitely a very important play part of the game here. Our preliminary findings confirm that we can save up to more than 20% energy, and even more in terms of carbon, if we are able to leverage this kind of computing continuum between all the resources, and of course communicating energy metrics. The last pillar that we have is open source. So everything is open, starting from our foundation technology, which is, as I mentioned before, Kubernetes in different flavors, by the way. So Kubernetes Vanilla, Kubernetes OpenShift, Kubernetes from Rancher K3s, KubeEdge. When we go to the very edge, Kubernetes is too heavy, so we leverage a KubeEdge. And let's say the glue logic among all those components, that is LICO, that allows us to move from different cluster, isolated cluster. We call them silos at the beginning of the presentation. So let's see that the virtual cluster appeared, and within the virtual cluster, we create those kind of single point of control of the virtual environment. So everything we leverage is open source, and also whatever we create, even the documentation, is open source. So we have mandated in our project that everything has to be concentrated and published on the FlUIDOS project GitHub, where you have all the components with README and documentation and blah, blah, that is needed for us to start and for us to share what we are producing with the entire community, scientific community. So in order to conclude, we have to present also something about use cases, because, you know, it's like engineers or scientists like to create technology, but in the end, somebody has to use it. So somebody has to find that useful. So in our project, we started with 3 use cases. The first is smart viticulture, which leverages this fluidity that we're creating within our project in order to make a seamless deployment of the different components at the edge, on the IoT devices, and in the cloud without much DevOps intervention. So it was possible before FlUIDOS, definitely, but the cost was much higher because of this manual configuration that was required to each piece of software that has to run. And by the way, the piece of software may be running on different locations, also based on different conditions like network connectivity. So if the network doesn't work very well, it's probably better to move everything at the edge. If the network is okay, maybe some components are better deployed in the cloud. So this happens transparently with FlUIDOS, and our partner is actually validating this way. The second partner is investigating about the intelligent power grid. The power grid is very important right now in order to guarantee survivability, resiliency, and so on. But probably you don't know that in order to guarantee this kind of properties, you really need a lot of intelligence behind it, which means in the end computing. And what happens if the computing part has a fault? That's the problem. So what we are doing here is that we're investigating how to make the ICT services that are required for the intelligent power grid more resilient, so that they can survive in case of faults or damage, or even if we drop the internet connection for whatever reason, maybe even for security. And the third use case is about robotic logistics, because we have a swarm of robots, a lot of robots in the factory, and maybe they can save the battery if they can offload the computing to another server or another robot, maybe which is actually charging the battery. So by sharing resources and batteries, we are better in the life of the robots, because they can live longer, they can work actually longer, they consume less battery. So in the end, the productivity in the factory is higher. And those are only the 3 use cases we started with, but we just closed the open course. So new 5 use cases are going to start in a few weeks in order to further validate our activities. And this is all for my presentation. You can find here some pointers to the website, to the Twitter or X, LinkedIn, social channel, and so on. For further questions, feel free to get in touch with us.
Thank you, Fulvio. Again, if anybody wants to extend a question to Fulvio, please feel free or raise your hand. Otherwise, we can continue. Then we pass on to Nefele project, and Anastasios Zafiropoulos is gonna present. Tasso, the floor is yours.
Sure, fine. Many thanks, Alexia, for giving me the floor. Let me share my screen. Nice. Can you see now the screen?
Yes.
Okay, thanks. So hi to all also on my side. My name is Anastasios Zafiropoulos and I'm coming from the National Technical University of Athens, and we are the coordinators of the Nefele project. So many thanks for the opportunity to present some of the highlights of the work that we do in Nefele, and we will be also glad to participate to any discussion that may arise. I will try to go through some of the main the core innovations that we have considered in the project and that we are working on during the lifetime of Nefele. We have two main objectives. Let's say the one has to do a lot with Internet of Things interoperability challenges. So how we can support openness and interoperability of different IoT solutions. And for this, we come up with the development of an open source software stack that supports virtualization of IoT devices that can be executed at the edge part of the infrastructure. And there we can tackle, as we will see a little later on, a lot of challenges related to protocols, semantic interoperability, security, advanced networking mechanisms, and also development of digital twins. This is the one part. The second part has also to do with convergence of IoT, edge and cloud computing technologies, and the development of a meta-orchestration framework, a synergetic meta-orchestration framework, as we call in Nefele, where we can develop mechanisms that we can foresee synergies among multiple entities in the continuum to support local and global decision making and to support the management of the distributed applications. Okay, as also mentioned by the previous speakers, okay, in the domain of edge and cloud computing, we focus a lot also in open source solutions. There are too many different solutions around tackling part of challenges around the continuum. And also, as mentioned also by Fulvio, some of them can be considered as silos. So there is a need to invest on convergence and interoperability aspects across the continuum, so as to come up with solutions that can be applicable in a wider, let's say, scope, while in parallel being open and modular. So given this, in Nefele, we follow a system of systems approach, okay, where we have a kind of an hierarchical decision making, where, let's say, the upper management entities have the responsibility for the deployment of applications and workloads across the continuum, from IoT to edge to cloud resources. However, the control, so the management, the pure management, is distributed in various nodes, in various agents across the continuum. And then we have an interplay of local and global decision making in the various layers, while a centralized entity like the synergetic meta-orchestrator is the one that has the overall responsibility for everything functioning in a good way during the operation of the applications. And under this perspective, we try to design and develop algorithms and mechanisms that inject intelligence and autonomicity in the various, let's say, layers. Now, coming to the two core innovations. The first one has to do with the EUCloud open source software stack. We have introduced the notion of virtual objects as the virtual counterparts of EUCloud devices. And we can have one virtual object that can communicate, can interact with a specific EUCloud devices, or in some cases where we have clusters of identical EUCloud devices, we can have a virtual object managing the gateway, let's say, that is managing the different devices. And in a higher level, we have composite virtual objects that can provide some extra device-specific or domain-specific functionality in terms of virtual functions, or a composite virtual object can accompany knowledge or actions coming from more than one virtual object. So you can manage, someone can manage actions that may refer to a more complex system. Here, it also resides the concept of the digital twin, because by adopting this framework and going to specific vertical industries, someone can design a digital twin that is mapped under the concept of a composite virtual object. So here we support different communication protocols, including HTTP, MQTT, COAP, and we try to continuously improve the stack. And we support interactions, both VOS and CVOS, virtual objects and composite virtual objects, are orchestratable. This means that they can be part of an application graph. So coming to the domain of cloud edge computing applications, someone can include in this graph entities that represent virtualized EUCloud instances and can manage all this part as an extended version of the graph, being orchestrated by an orchestrator or a meta-orchestrator across resources in the continuum. So these are things that we work a lot. For the virtual object stack, we have an open source release that is based on 3 layers. We have the physical convergence layer, where we support different types of communication protocols, and we invest a lot on security aspects for the interplay between the EUCloud devices and the virtual objects, and also networking functionalities, and especially we support functionalities for time-sensitive networking for the interaction between the various virtual objects and the EUCloud devices. So we have a specific agent for it. In the backend logic layer, we have developed an EUCloud data store where we can store data coming from the EUCloud devices, and also a lot of generic or EUCloud virtualized functions to enhance the functionalities that can be supported in the edge part of the infrastructure for the EUCloud. And in the upper layer, we have, let's say, the convergence layer, where we try to make EUCloud technologies interoperable with cloud and edge computing systems and platforms. So here we have challenges related to semantic interoperability. Different models, different semantic models have to be supported by translation mechanism. So an application developer that has modeled an application managing data through a specific model can use the VO stack independently of the model that this stack communicates with the EUCloud devices. So this is one great challenge that we work. And we also work a lot on orchestration. So we provide orchestration interfaces, as shown in the previous figure, where these VOs and CVOs can be managed part of an application graph and managed in a unified way. Now, we have two versions of this stack, because we try to cover specifications coming from the Open Mobile Alliance, LWM2M specification, and also the W3C Web of Things specification. So we have released open source versions of this stack. And especially for the Web of Things part, we have continuous interaction with the W3C Web of Things working group. We try to follow the specifications as they evolve from this working group, but also in parallel try to contribute on our side with some extra functionalities that we develop and are specific to the NFLA project. And it is a great work there, and our work is also including in the releases of the relevant softwares by the Web of Things working group, so it is available in the relevant website. Now, coming a little more to the orchestration domain, we have tried to develop an architectural approach for meta-orchestration. To reach at this point, we have identified the various stakeholders that may cover different aspects of the continuum, and in some cases, there may be some overlappings. One stakeholder may undertake more than one box, let's say, in this layer, considering the operator of the NFL platform, cloud and edge computing providers, IoT providers, network providers, and application service providers and service consumers. And we have followed existing specifications coming from ISO 42010 standard to specify the viewpoints, the different viewpoints of our architectural approach, considering foundational, business, usage, functional, trustworthiness, and construction viewpoints. And this has led us to the specification of the architecture, considering the meta-orchestration platform, the VO stack, and a development environment that assists developers to onboard virtual objects and applications in the platform. So in a high level, I would say that the flow is that we have a specific development environment where an application developer can use to develop and make available application components. We offer a dashboard that someone has access to this development environment and also to the synergetic meta-orchestrator. And on the synergetic meta-orchestrator part, we follow what we call the system of system approach, where we have a high-level entity as a synergetic optimization engine managing the life cycle of the deployment of an application graph. But this goes down to multi-cluster resource manager, doing optimizations in a per cluster basis, management of the virtual objects, and also to network resource managers that can facilitate requirements and needs coming from the networking part. And this goes down to the specific clusters and the scheduling, scaling, and monitoring mechanisms within the clusters, and for sure to resources spanning across the continuum, including the IoT devices. So we work a lot at this period to inject intelligence in the various boxes here and to manage the different control loops in this hierarchy, so to make reliable and consistent mechanisms to support deployments, considering different objectives related to performance, energy efficiency, security, and others. In all cases, we consider deployment of application graphs, where we denote requirements, both in component, node, and link levels, specific properties that have to be guaranteed, and constraints in the form of restrictions. And we have high-level service level objectives that we want to satisfy. In FLM, okay, this graph can be translated to deployment in different clusters or in different administrative domains of an infrastructure, where the high-level requirements can be translated to specific link requirements or activation of specific functions to guarantee them. And we try all this kind of mapping to do it in an intent-based way. So we try to work on the formal description of an intent, considering both compute and network resources, and how we can translate a high-level intent description to different policies that can be activated in the different levels of the approach that we have shown. So a lot of control loops work and is coming into play, considering always orchestration in a multi-cluster environment. So to achieve so, we have defined a methodology that we manage the life cycle of the intent per se, from the description of the intent, the translation to proper mechanisms, specific loops for planning actions, implementing the actions and validating continuously that we achieve the targets that we have posed, and leading at the end to also report that if this intent worked and is achieved and it is something functional that can really work in a deployment. Here it is a lot of work in progress that we want to achieve in the upcoming months to come up with some solid description of both the intent and the developed mechanisms. In many cases, we consider synergies between multiple agents. So we speak about resources in the continuum, we speak about agents. We try to work a lot on AI-assisted orchestration. So we have synergies between agents with local and global ML models that can be applied for optimization purposes. And for instance, we have worked in this period in auto-scaling mechanisms for serverless workloads in the computing continuum, considering reinforcement learning decision-making, where we apply agents in the various parts of the continuum to manage the auto-scaling part, and we have seen that we can achieve better use of resources while guaranteeing or having less violations in the SLAs that are applied in the infrastructure, starting from an intent, moving to the SLAs and to orchestration actions. And now all this work is going to be validated. It is work in progress also, implementation of the use cases. We have use cases in the domain of emergency and disaster recovery solutions, considering sensor-carrying robots that support specific actions in specific areas, including operational in the area of a port. And we have a use case related to energy management in smart buildings, considering virtualization of a lot of IoT devices in a smart building, management of the virtual objects and orchestration of the applications, and also activation of security functions, in this case, authorization and security functions. We have a use case targeted to smart ports, logistic operations in ports, actually in the port of Luka Koper, with a lot of route optimization and AI techniques to support the optimal operations in the port, again managing distributed applications deployment over both compute and network infrastructure. And we have also a scenario related to remote healthcare, where we virtualize devices that support ultrasound medical imaging. We virtualize not the devices, functions that support operations of the devices, and we try to take the computing load of these functions at the edge part, while in parallel give real-time access of such processes to remote operators of a medical, let's say, process. And okay, last slide. We have 2 open calls. We have actually today we had the welcome event for the 8 projects that were selected for the first open call. And we have really nice submissions. And in the first open call, we focus a lot on the extension of the functionalities of the open source software stack for the IoT part. So we accommodate the development of virtual objects, composite virtual objects, and solutions for extensions of the stack. While a second open call will come within Q3 of 2024, where we will focus on the meta-orchestration platform and the deployment of different kinds of applications in various verticals, considering the overall continuum. So that's all on my side. Many thanks for the attention, and if there is any question, I will be glad to discuss with you.
Thank you very much, Tassos. There is actually a question from Belen Gallego. So, Belen, please, you can talk now.
Hello.
Hi, we can hear you.
Hi, Belen.
No, I have no question, in fact. So
I saw your hand raised.
maybe I push on a button. Sorry for that.
Okay.
Brilliant presentation, by the way.
Thank you.
Thank you very much for this webinar that is pretty interesting for all the attendees.
Thank you, Belen. Okay, so no question then.
Fine. Thank you.
Yes, thank you, Tassos. And we are right on time to go to Nemo project, which is represented by Terpsi Velivasaki.
Okay.
Hi, Terpsi.
Hello, everyone. Just let me share my screen. And just a minute. Okay, just let me know if you can see my presentation in presentation mode.
Yes.
Yes, Terpsi.
Okay. So thanks for inviting Nemo in this really interesting webinar about discussing the developments around the current MetaOS landscape. I am, as you already know, Terpsi Velivasaki, the technical coordinator of Nemo, representing Synelicis. And let me just begin with what we have in Nemo towards this topic. So the main concept in Nemo is actually to build a meta operating system like the rest of the project, but the focus here is actually on enabling multi-cluster and multi-network orchestration of containerized workloads, whatever kind of containers these could be. They could be different technologies of containers like Docker. It could be even unikernels for increased security. And this to be done seamlessly across the resources of the Continuum IoT Edge or cloud. So the focus on Nemo in building this MetaOS is indeed to make it user-centric, to be able to attract developers, to build on top of it, to develop on top of it, and in the end to let different parties, different entities interact and creating revenues out of data, applications, but also resource transactions. So the idea is not only to focus on the workload delivery per se, but also to enable the integration of third-party resources, whether they are computing or networking, and thus allow democratization of the resources for the general public as application users. Excuse me. So the Nemo vision is depicted actually in our meta architecture. The high-level part is depicted here. The idea is to bring on-device intelligence and enable artificial intelligence of things, make the different types of devices interact in a way that this is done seamlessly without intervention and across the different resources of the platform. We aim for a transparent IoT to cloud continuum. We've put a focus on intent-based dev zero ops tools and plugin mechanism, intent-based in order to facilitate the integration of third-party managing roles either on the service or the network or the infrastructure layer. The target is for providing this the whole framework as open source and having a modular design, cloud and edge native based, in order to allow the open source community not only to use but also contribute to extensions. And also by opening this ecosystem, we target to attract massive AIoT application developments and thus have increased penetration for this Meta operating system. So as you can see in this architecture, we talk about a full stack Meta operating system, fully open source, covering functionalities from the infrastructural part, integrating different types of network resources, and then integrating different orchestration platforms on the service control plane. On top of that, we have what we call the service management layer, which exposes the NEMO functionalities to third parties, to external users. And this includes the plugin and application lifecycle management platform, which is the way to add extensions on NEMO as plugins. The part that refers to the accountability component, and also an intent-based SDK API, which exposes programmatically the NEMO functionalities. Also, we have the three cross-cutting functions referring to federated MLOps, cybersecurity, and also person policy compliance. In terms of validation and piloting, actually in NEMO we have quite a large number of use cases within the project. So far we have defined 9 use cases in the 4 living labs we have. One is related to smart farming and is located in Greece. Here we have 2 pilot use cases referring to maintaining organic farming, sustainable organic farming with the use of autonomous intelligent devices like UAVs and mobile robots, allowing intelligent biospraying decisions and autonomous mobile robots catering for the weed management in olive groves. So the idea here is to make use of the NEMO resources in order to allow the allocation of the different types of workloads, especially the most intensive ones in terms of computation mainly, that refer to machine learning training, into across the IoT edge and cloud resources based on user-defined intents. This also could accommodate metrics and requirements for green energy usage and reduce the optimize the energy consumption. So we have also a focus in the project for greenifying to some extent the technology of orchestrating these types of infrastructures. The second pilot is located in Italy and is related to smart energy and smart mobility. We have here 2 use cases again. The first one relates to the optimization of the smart of the operation of the smart grid and the integration of demand response capabilities, aiming to optimize not only the energy availability, but also enable better integration of renewable energy sources without affecting or compromising the stability of the grid. So for this, we leverage on, again, machine learning models based on reinforcement learning in order to benefit from knowledge that is generated from different types of devices, including smart meters, PMUs, the SCADA system, whatever, and also renewable sources. We have here ASM leading this pilot and providing all this type of infrastructure. The second use case is about smart mobility. Here we have a fleet of electric vehicles and smart chargers, again internally. Here the focus is on optimizing the traffic prediction and the parking process, but also at the same time combining this with available information regarding the green energy availability and the scheduling of smart charging. So this is again piloted internally. Where the idea is to distribute the machine learning processes across the edge devices and the cloud devices, collecting monitoring information about energy demand and response and green energy availability, to get referring to the smart charging, to the charging operation, in order to optimize this within the pilot. So NEMO is indeed exploited for meeting the business objectives, the use case objectives, while at the same time optimizing the use of resources and the integrating better the renewable sources in the grid. The third pilot is related to smart manufacturing and Industry 4. This pilot is located in Germany and is led by Continental. The pilot here aims to, we have again 2 use cases, is on automating the processes within the factories related to the transportation through AGVs, sorry, and at the same time ensuring human safety, the safety of the human workers, which means to avoid collisions between the robots and humans without, again, any intervention, but having automated autonomous robots there. A challenge here is that the decision, the detection of the human workers has been done quite fast, must be done quite fast, because the robots are quite big and not very easy to stop on time if an event of such a collision arises. So again, here we leverage NEMO. We leverage 5G, private 5G networks with TSN, time-sensitive networking, for the synchronization and communication of the mobile robots, in order to optimize the decision and object detection, machine learning-based object detection, and at the same time make the best use of the available energy in the edge and cloud resources of the pilot. The fourth trial has to do with smart media and XR and smart city. So here we have two quite diverse use cases. The pilot sites for both are located in Greece, in Athens. One relates to the Athens Marathon, and the main objective of the use case is to enable automated tracking of the runners in the marathon, and enable through the spectator's mobile phone, and enable the spectators to exchange information about it. Here again we have machine learning-based object detection together with advanced networking for the delivery of this content, which is quite network intensive. And in the pilot, we have set up a local 5G network in order to test it in a stadium that is located in Athens. The second part of the pilot has to do with XR applications, which is done in the pilot site is in the foundation of the Hellenic World here in Athens. And here the focus is on the delivery of applications with, again, very intensive content in terms of both computing and networking resources. And giving the opportunity through NEMO for different user roles to interact and communicate in real time events that relate to the delivery of 3D content or other immersive applications. Apart from this, we have two laboratory environments for validating the activities. The first is in one lab in France. It's one of the 5 biggest experimentation infrastructures in Europe. And this hosts the development, staging and production environment for NEMO, providing all different kinds of resources across IoT, edge, and cloud. So the possibility for different testing different types of scenarios. And the second one is an IoT 5G lab in Finland that is hosted by our partner Kumukor, and which is active and in charge in the project of the development of the TSN functionality around a 5G core prototype that they have developed in a previous project that we are based on a lot, IoT Engine, which is brought up here and further extended in NEMO and used for piloting for the pilot of Germany in the smart industry. So, moving to some details on the alignment of our activities with the activities of this EUCloudEdgeIoT community. We have been following the activities of Task Force 3 as the rest of the projects, and have made an initial exercise of aligning the components of our architecture with these functionalities envisioned in the proposed reference architecture so far by EUCloudEdgeIoT. As you can see, I tried to put everything in one slide, so it's not that visible, but in the big picture, we can see that NEMO provides functionalities more or less related to all the functional layers of this reference architecture. You can see in the arrows colored in their background with the same color as the functional layer of NEMO architecture that covers this part. So more or less, as I said, I align with most of the functionalities, but we could say that the stronger focus is on the orchestration part and the network one. These are the core targets of our project. I would now proceed with some more details on what kind of functionalities are supported in these different functional layers of the NEMO architecture. So starting on with the network part, the network infrastructure management. The basic component here is what we call the federated meta network cluster controller. This one provides a control plane over the networking resources of diverse resources, I mean, across different providers. So here, this component is able to create slices between nodes belonging to different administrative domains. It integrates with different network adapters, so it can easily accommodate different types of networks. And also, there is support for multipath communication depending on the user requirements, the application requirements, and also provide support for service migration across these domains. I would say significant contribution on this part relates to intent-based networking. I listened before another project that had contributions on that part. Maybe we could somehow interact on this. So for this MNCC, what we call the intent-based network management module has been developed. It is in a beta version right now, and has been contributed to IETF by Telefonica, which leads this task. We have made 3 contributions so far. The next component, that is the next major component in this layer, is the one that I mentioned before, around the 5G core. It is a prototype right now and integrates TSN that allows the creation of 5G LAN following the 3GPP specifications, and also allowed for network slice creation for isolating different applications based again on user-defined intents. The next functional layer is our NEMO kernel. Here, the major component, the central component, is the meta orchestrator. This is considered as a central orchestrator of these containerized workloads that are distributed across the Continuum. It is based on an open source project, the Open Cluster Management. It's cloud native as well. And right now we have, again, a working prototype that allows for intelligent service placement across the continuum, and also for migration across different types of clusters and domains. So for the migration part, it collaborates a lot with what we call the intent-based migration controller. We have the cybersecurity microservices digital twin. This is a component that caters for the service discovery within the MetaOS. This also supports observability across the continuum and sovereignty of the relevant operations, because it is also integrated with distributed ledgers for immutable information around the any actions that have been applied on the workloads across this MetaOS, and which could refer to service deployment, migration, or any kind of event that has to do with this load. So provides increased observability and auditing. The kernel part also integrates a component that ensures increased cybersecurity during execution. It is the secure execution environment. It provides just execution environment runtime and unikernel support. We have, again, a prototype solution for that. And it provides also an extension for migration on top of Kubernetes. The next set of functionalities have to do with the service management of NEMO. Here, the first component delivers lifecycle management services for plugins and applications. By applications, we mean, of course, the ones that run on top of NEMO. By plugins, we could consider any type of workload, even the components of NEMO per se. So we have a common approach for the development and lifecycle management of both the infrastructural components of the NEMO components, any additional extensions that are typically considered as plugins, and also third-party applications, the ones that are brought by external third parties to run on the developed MetaOS. As part of this component, we also support events monitoring that are mainly related to cybersecurity incidents that could take place while the workloads are running. So at the execution of the workloads, and these work as sidecar containers on the same pods with the applications and plugins, and also provide automated event response to such types of events, which again is modular and can be easily extended. The service layer also includes a component. This is the MOCA component that enables monetization and accountability services based on smart contracts. It is actually the component for, on one hand, providing an interface to the NEMO providers, infrastructure providers, application providers, application users, and so on. And supports monetization on top of such kind of transactions based on DLTs and smart contracts. And last but not least, this layer hosts also an intent-based API and SDK. So the idea here is to give something that is similar to what developers are already familiar with, like the Kubernetes API, and expose the NIMO services in a programmatic way. So on one hand, to expose the NIMO functionality, on the other hand, to do this in a developers-friendly manner, and thus foster its adoption. Security, privacy, and policy enforcement are ideally considered in NIMO. These are considered as vertical functions. We have two components here, the present policy enforcement framework and cybersecurity components. It's not only one. The idea for the first is to automatically enforce policies that could be class-specific or user-specific or even privacy-specific, and do this in a homogeneous way for all the clusters or orchestration platforms in this continuum. And on the cybersecurity part, we have adopted a zero trust approach, providing privileged access to the different types of services that we offer. For this, we support identity management across all the continuum. We leverage encrypted communications across between the NIMO components, even if they run in different clusters or different domains. And also, we provide an access control mechanism for imposing multi-criteria access controls at different layers automatically. Last, we have a layer that provides federated MLOps. This is the component of NIMO called Cybersecure Federated Deep Reinforcement Learning. This one combines advanced learning techniques like federated learning and reinforcement learning. The developed algorithm is going to be applied for the supporting the meta-orchestrator in its decision to place the workloads at the different nodes available in the continuum, given the application and resource requirements. We also provide some contributions around cybersecurity and gossip learning, which is a type of distributed and non-centralized learning. And also several contributions around cybersecurity and privacy preservation, focused on federated learning. For this, we have a solution for dataset generation based on generative adversarial networks, and leveraging this for the attack detection and mitigation that could take place in federated learning systems. So, automation is core at all parts, I would say, of this developed MetaOS. We can see here how we have implemented the DevSecOps approach in NEMO. We are based on GitLab CI/CD, which has been applied for development stages and production environments. And within this process, we have integrated security checkings at different steps of the software development lifecycle. This starts by the code development, to building, to validation and verification, and also during application delivery and execution. So what can be expected now for the future of this continuum? We tried here to collect what we could consider as next steps not included in our GAs, and which could leverage on cutting-edge technologies right now. The first we have identified relates to generative AI. It is now, I would say, realizing a big penetration in several domains in software development, and we could also think of this being integrated for automating and facilitating the interaction between humans and MetaOS, and also having this present in several DevOps related functionalities like in MLOps and DevSecOps, in order to have, let's say, the possibility for less technical skilled personnel to get involved with managing these types of services. The development of relevant skills is another big discussion, I would say. So maybe generative AI could address this lack of skills in some domains. So the second identified topic for this would be to take a strategic approach towards the cybersecurity MetaOS. We have seen and have been developing or adopting common cybersecurity practices, but I think that this is done in somehow a fragmented way. So this could be done in a more strategic way, like having hypothetically a cybersecurity code of conduct for the development OS. Once this is actually adopted, for sure ensure present GDPR compliance. PRESS refers to privacy, research, ethical, societal, scientific requirements and concern by design and by default. And this smart, intelligent orchestration of all available resources across providers, across countries, and so on. The network integration part is quite important. We have seen again a fragmented development so far. This should be taken in the next step, with having this realized for integrating wireless and wired networks, able to support real-time immersive applications through different types of devices, and with very high requirements in terms of latency, in terms of content, and so on.
Sorry, Terpsis, I'm really sorry to interrupt. We're running a bit behind time, so we need to wrap this up and pass on to the next speaker, okay?
Okay. I will close right now. This is the last one. Again, miniaturization of the orchestration frameworks in order to have integrated different types of devices, protection of open sourcing, because we have seen now unexpected closed sourcing for several well-known frameworks like Terraform or Redis. Greenification of EU-wide MetaOS infrastructure and technologies is another challenge. Large-scale piloting in order to ensure that these outcomes are actually feasible and valuable, and also provide at EU level incentives for building and investing on this MetaOS. This is the last one on the open calls. The first has been closed with 6 projects selected. The second one will open in June 2024. So I will not take more time. Just drop us a line if you need any more information. And thank you for your attention.
Thank you so much, Terpsy. And yes, whoever wants can send their questions. We will pass to aerOS project. Apologies for running a bit late, but Ignacio, please, you can go ahead.
Yes, hi Alexia again, and hi everybody again. No problem. I know conversations here can take long, and it's how it goes. I think I can share my screen now. I think you need to stop sharing. I don't know who.
Yeah, you are right.
Yep, and I will share mine now. Okay, so first of all, I would like to say thank you to the previous speakers and also to the next one, because we are learning a lot from your architectures. We, of course, personally as project participants knew some of your insights, but today you are going clearly deeper than before, and this is appreciated. From our side, from aerOS, we have tackled or addressed this presentation a bit differently. We have decided to focus on the things that we believe are more relevant from our side in terms of particular and pragmatic innovations, because of course we also cover security, privacy, and all other aspects. But we thought that for the little time we had for performing the presentation today, we should focus on the most relevant aspects from our opinion. So I will start with it. Our view at right now. So aerOS project, same as the others that has been explained this afternoon, started in September 22, will end in August 2025, 36 months of duration, 27 partners, around 11 million and half of budget. And our goal is, of course, our overarching goal is, of course, to design and build a virtualized platform agnostic meta operating system, same as the others, to manage and allow a better and more efficient usage of the IoT edge cloud computing continuum, meaning every computation capable element ranging from devices close to the IoT side and more centralized cloud side, so that the workloads can be executed on these elements independently of the underlying hardware, operating system, and equipment, of course. For doing that, we designed a 3D box architecture, which is divided in aerOS runtime, basic services, and auxiliary services and user services, with the idea of using context awareness to distribute software task application requests, similar to this intent-based soft service level description that has been mentioned across other projects, supporting intelligence as close as events as possible, so that moving beyond the classical decentralized perspective that any kind of AI, if it needs to take place, it needs to take place on the cloud, and all the decisions are taken there, and then the rest of the elements just execute the will of this centralized element. This is not the case any longer. to our perspective. And I think this is shared in the hierarchical view of NFL or the distribution from FlUIDOS that we have been seeing today. So we also convey that message and agree with that perspective. Of course, we also use some kind of a service description and a resource description so that we can make proper matches of what the service requires, what the user intends to do, and which are the available resources that can be discovered and used. So everything is with the data models and the expressions that we are using based on open source and common literature, but also from some developments of our own. We leverage the network underlying to make them connect, discoverable, analyzable for taking smart decisions. The main and primary goal is to make this allocation of the workloads efficient and allowing to have an underlying layer that understands this allocation order and interprets it to resolve the complexity of potential underlying equipment. Unlike other projects that we have heard today, aerOS is going beyond only having only Kubernetes as its centralized technology. We do manage it and we do use it, but we also consider elements in the continuum and do not equip necessarily this kind of technologies that are still be able to join a continuum of aerOS that can have it running services upon it. So also one of our main focus, and you will see later in the slides, is in data description, data autonomy, and data interoperability. We have in our consortium relevant partners that are part of clusters such as GaiaX, DSBA, Fireware, and other entities that have their own approaches for data description, data exposure, etc. And we are leveraging that aspect as well on the fly, batch streams, etc. of data. So it's a strong position from our side. Also, the technology is being deployed in several use cases, which we call pilots, in 5 different environments. Manufacturing environment, we actually have 4 use cases there with relevant industrial partners that are willing to adopt our technology, and it's already being done. Renewable energy. So we have a containerized, literally physical containerized nodes that can be placed near renewable energy sources. And with the orchestration mechanism we provide, we can make this even more efficient in order to take advantage the resources in computation wise in terms of energy consumption. We also work with John Deere with mobile agriculture machinery maintenance, so that there are some electric tractors that move around in platooning scenarios, and how they process the information that they gather IoT wise and mobility wise, etc. It's made more efficient, and the production is improved thanks to aerOS mobility services. We have a pilot in the smart buildings case where we have different flats in a building that monitor the heating conditions, the environment, and where the seating workers are there, to make some recommendations to make the energy efficiency more real in that building, also leveraging 5G equipment. And also we focus on image and computer vision side in a maritime port, checking defects in containers, and also tracking the container handling equipment movement across a terminal yard. And all of this making decentralized so that these movable elements can equip enough computation to make part of this continuum and contribute for common learning among all the elements. As you see, pretty varied use cases where our technology is being developed. And talking about the technology, needless to say, as Tepsi said, we are participating in all the working groups of the Task Force 3 for agreeing into a common architecture landscape or the pre-normative document, but especially we basically focus on, we devote to all of them, but we were the leaders, or we have been the leaders of the orchestration working group, the block. So we have tried to gather the idea that have been today very well exposed here from the other projects with our own concepts, trying to have these aspects defined, such as the dual multi-layer orchestration, the reallocation, the triggering of this reallocation, or rescheduling, how to decompose these services, etc. And we believe we are in the good path in that regard. Also, strong points of our project where we believe we are bringing innovation are this data accessibility and interoperability, being able to orchestrate workloads to different underlying management frameworks, container management frameworks, and the global automation. We are devoting several resources and time and teams in our partners to try to make this as little customized and difficult to use as possible, like everything with just a few clicks, just a few scripts for installation, just a few understanding, for it more user-friendly, everything is scripted and automated, or we are trying it to do it that way. So we believe this would be a very positive outcome, innovating the field from aerOS as well. Same as other projects, we are developing our own components in some cases, and in others we are just leveraging, customizing, and enhancing some open source available tools such as KrakenD, Fireware, or Orion LD, EUCloudEdgeIoT.EU RIA as well. As I said, we are compliant with the Kubernetes perspective as well, but not only to Open API, Helm charts, well, many technologies that of course our documentation is public, you can check if you want. That's the spirit we are following. One of the main things that we believe is relevant, and before passing the floor to the technological leader of the project, Vasilis, which is here with me, just to give one hint, because there was a question before today in the session by Tassos that said, well, what kind of technology could be used for a hierarchical decision or orchestration? This is a very valid question, and I know he and his team they are solving it. But we made a different question that was, what kind of technology or how we can approach a completely decentralized decision making, not hierarchical, although in every continuum you have some sort of hierarchy, because there are nodes more capable that are closer to the cloud definition, and nodes that are less resourceful capable, so are closer to the IoT definition. So there is a conceptual hierarchy itself. But for the decision making, we try to think, well, how can we approach this in a way? And we decided to create this distributed state repository for different domains. When computing resource domains are defined, which are rather heterogeneous, that contain different technologies, different processing architectures, etc., we define them or wrap them in conceptual domains, and in each of them that can be local or can be distributed across different geographical location, it doesn't matter. We gather and monitor the information that is contained in different context brokers that contain the information itself of the current value of current status of this continuum, the network, the services ongoing, the resource being used, the total resources available of their local elements. But then, thanks to cross registration subscriptions that we automate in a way so that they consume as less network bandwidth as possible, we're able from any point of the whole continuum of domains that join aerOS perspective, we allow them to be continuously aware of everything that's happening everywhere, so that every piece of these domains can take a decision based on the whole status of the continuum, not only on the local side. So you there avoid the need of having a unique centralized entity. So it's kind of moving the concept of orchestration in to the old concepts of this decentralized peer-to-peer available data everywhere networks. And for what we can relate so far, this is working pretty well, and it does not imply too much overload that we thought it could have. So that's one. I thought this was relevant to be mentioned because this is one of the key pillars that we have underlying in our design for allowing orchestration, data distribution, trust indicators, non-repudiation in messages, etc. So everything is connected in this way. Good. Now I will pass the floor to my colleague Vasilis here that will explain you a couple of things. Then I will retake.
Okay, hello, thank you, Nacho. Hello, everybody. Now we will proceed trying to present the components and their design principles that implement the core aerOS functionalities. As Nacho said, we have a philosophy of peer and distributed orchestration, and all the services of aerOS services are peer running in each domain, and they are distributed. And starting from the orchestration, that means that they are the orchestration service is deployed not one in a hierarchical way, but in each domain, and they are working either autonomous in a synergetic way. Now, the orchestration is the first of these services. It's quite sophisticated, and it develops on top of some key concept, and the first of them being that is the federation of information. As Nacho presented before, there is a registration among all the domains, and so at the cost of just one question, each orchestration service running everywhere can have access to all the capabilities and the runtime availabilities, current availabilities of all the resources, available processing units, processing resources that can be available to host any service. It can also see have all the services that are deployed on this hosting elements and their connection. The orchestration can build on top of this information and make use of this information, federate information of the status of all the continuum at its time. Now, the next key concept is the orchestration implemented in aerOS. It's implemented in two layers. We have followed, let's say, a principle of separation of concerns, and we have one component that undertakes the decision. It's the decision engine. We call it the high-level orchestrator. This takes advantage of this federated information across all the continuum, across all the status of all infrastructure elements and what they can provide at each specific time at the cost of one question. And on top of this information, it can make the best placement for the requests for deploying the service and their components. So, in fact, the first high-level layer of the orchestration is solving each time a double optimization problem. On the one hand, having the requirements of the services that needs to be hosted. On the other hand, having the availabilities, the capabilities, but also the current state, the current time availabilities of all the hosting infrastructure elements. So, solving this double optimization problem, it produces among several candidate infrastructure working nodes that can support hosting nodes that can support these services. We call them infrastructure elements. It makes the decision and assigns the deployment to one of these. So this is not a job of the high-level orchestrator. We have the lower-level orchestrator, which is the enforcement engine of the orchestration service, which actually receives the decision and just knows how to talk to the underlying infrastructure, knows the language, let's say, of the different frameworks that can host the workload deployment, either being Kubernetes, Docker, container for the time, but this is expandable. So, in order to receive this request, they have used a slightly customized Tosca model that can support all the description of it's built in very user-friendly, let's say, user interface, which compiles at the end a Tosca model, Tosca file, a YAML file, which is very standardized and can describe all the needs and the requirements of each service that needs to be deployed. This includes the constraints of the service, the specific requirements, the service license agreements, and everything. This is received by the exposing endpoint. We have all the OpenAPI specification, and we have exposed some services. It's received by the first level of the orchestrator, and internally this follows a process where messages are exchanged from one component to the other of the high-level orchestrator, and all these messages are quite very well modeled and specific modeled, and they are exchanged through a lightweight messaging protocol, Kafka protocol implementation, which is the Red Panda. So all the messages are exchanged through this messaging protocol, and until they reach the final decision of the high-level orchestrator, which is then propagated either locally to the low-level orchestrator if it's a decision to deploy something in the local domain, or calling again a remote local orchestrator for deploying a part of the service, a service component, somewhere else if the selected infrastructure element is not locally allocated. All this messaging is well modeled, and this the decision, the actual brain of the decision engine, which is the AI engine, is using AI algorithms which can be exchangeable because they are very well modeled, all the interfaces and the message exchange, and so one can place a substitute to the AI engine. So this is the concept of the orchestration, and this is based, as we discussed before, on the availability of the information across all the continuum. This is provided by the data fabric, and the data fabric, at the heart of the data fabric, let's say we have the aerOS knowledge graph, which is hosted at the context broker, and this hosts all the information. We are using a custom smart model based on NGSILD, which hosts all the information about the processing units and all the elements across the continuum, the services that are deployed or need to be deployed, and their connecting services with hosting units, requirements, and constraints. Now, in order to achieve this, we have followed a complete build a fabric, the data fabric, which implements a pipeline. On the one hand, let's say at the end left, we identified the sources, we catalog the sources, we use metadata to know everything about the sources, the ownership, and all this. And now this information is going through a pipeline which makes ingest different kind of data at real time, can annotate, make semantic annotations, translate, transform them to the model that we are using, and pushes this to the heart of the context broker, which, based on the registrations that Nacho referred to before, they are shared at each time all across the continuum. On top of this, there is the product manager that not only orchestrates this process, but enables the integration of ownership, privacy restrictions, owner of each data model and each data piece. So it's very granularly, and in terms of security, handle at the access control at the exit point of this data. Who can consume it, who has not the permission to consume each piece of information. Now, after we have discussed the orchestration, the data fabric components, now in order to make them easily deployable, reusable with security and privacy, we have developed the methodology, which is a development and operations methodology, but having in mind from the first moment of development and before the deployment, the privacy and the security aspects. So we have made a great effort here not to build something that then recursively at the end we come back to make security and privacy validation and then go back to the beginning to make adaptations, but to take into consideration from the first step how should we develop and to provide all the toolset and the methodology to have by design security and privacy in the development. So we start by providing tools and methodology that start from the planning, from the first, let's say, step, which is the planning of the methodology of the development, where we take into account threat modeling about security and privacy. They provide tools in the development environment that provide security analysis of the static security analysis and integrated in the development environment. And this process all after we have passed the static application security testing and everything, they are pushed to the repository, source code repository, where a series of automation tools are built inside to run validation test, software composition analysis, to build the image and to make the deployment in some testing servers, pre-production servers, where they also pass some dynamic application security testing and every load testing. And if everything works as expected, the orchestrated automation or the automated orchestration can proceed to make the deployments on the real server where they are validated, monitored all the time, and the feedback is going back again to the repository for more adaptations. So having deployed the methodology and the components, we also have designed a methodology to deploy all the components that support the aerOS orchestration and federation across the continuum from edge to cloud. Thank you, Nacho.
Yes. Thank you, Vasilis, for the great explanation. I would just like to, as I see some people dropping by because we exceeded the time. Unfortunately, I will just skip this part because I want just to also bring some reflections for the community that are hearing us about potential next steps after all these developments that we are doing. And for us, for instance, for two research lines, we go through autonomy, traceability, governance, network automation. It's super important, and the increasing miniaturization of workloads, not only the computing elements and the actual hardware, but also the service and workloads, the federation in multi-stakeholder scenario, and also, metaverse, tactile deployments, and bringing automatically GDPR into the flows of life cycle, as we have tried to start with in the previous methodology that Vasilis explained. Also, and also talking about what we are bringing to the community, I would not like to close our part without mentioning the open calls of aerOS. We have 2 rounds, and we will be funding 900,000 euro. First round concluded last January and will be starting right now. The projects will be announced very soon and will start. And the second round of open calls, which we will open for other new verticals, will start in May. So please stay tuned for the next advances and the next news of the project, and you will be able to have the opportunity to participate with us. That was all. Thank you. Sorry for the delay. And now passing the floor to the next presenter. Thanks.
Thank you, Ignacio. And we have now here Horn from Nebulous Project. So here, please go ahead, and thank you to all attendees for staying with us for a little bit more.
Thank you very much. I hope that you can see my screen now, and I will going to present the Nebulous project, which is, as all other projects here, a meta operating system, which is dealing with the sort of application virtualized deployment in Kubernetes clusters. And I'm coming back to this. The challenge that we are trying to address is basically summarized here, where you have multiple applications, and each application can have components in different positions in the domain of what we can call rented or virtualized resources. It's also possible to bring your own nodes and your own resources in this picture, of course, and this is then not being shared with other applications, but these resources are then reserved only for your application and participate in the same Kubernetes cluster as all the other components of your application. So the whole idea is that we manage each application across this domain. This is fairly easy when it comes to the cloud and also the fog data centers, where it's possible to acquire resources, and the actual resource provisioning is being done by the data centers or the providers in that areas. But when it comes to cloud, when it comes to edge servers, then of course the resources are being physically shared among applications, and whether a resource or a server at the edge supports virtualization, so multiple applications can run at the same time, or whether it is taken by the first application coming requesting that resource. This is a much more difficult situation where different applications start competing. So for that, we actually have built in some auction mechanism for resources that are constrained in that way. So if you look at a normal operating system, then you have certain salient aspects of that, like the kernel, you have the hardware management, you have input, output, networking, security, and of course you have some kind of user interface. And for Nebulous, we are, as the name indicates, a MetaOS, which means that we are not interfering with the kernel of the nodes that we are managing. that is being done by a normal operating system. So the only thing that Nebulous does is sort of interacting with that Nebulous, with that kernel. And as we said, we have Kubernetes as sort of a middle layer here. So each application has its own Kubernetes cluster, and the MetaOS that we are representing, we are just sort of pushing jobs or services or pods to these nodes, different nodes. We do, however, manage the hardware. So the hardware that is available for inclusion in that cluster is done by Nebulous, and we're also monitoring the SLA. So if you come with some kind of hardware equipment and you claim that it can do something for the application and it cannot, then we will exclude that from being selected for the deployment of applications. We also manage the input-output of the applications in the sense that we have a distributed event management system. So the application types we're looking at, they are long-running and they have some kind of variability over their lifetime, meaning that these applications will need to have some kind of scaling in, scaling out, changing the placement of different components, etc., according to what happens with the use of the application. So number of users or data being processed can cause complicated events to be triggered. And all of this is being handled by Nebulous. And then we provide a secure data communication among the nodes of the Nebulous cluster. So each application has its own private networking, and the data will not be seen or interfere with the other applications being hosted by the same physical node. And then we have also an AI-based anomaly detection mechanism, which detects if some nodes start to behave differently from what is the expected behavior. The key features, you have a set of tools that allow monitoring, that allows the modeling and the definition of applications and their requirements for the application components. We have multi-criteria resource brokerage. We have contracts that will be made smart in the next iteration, next release, that looks after the service level modeling. We have reactive and proactive reconfiguration of the applications, as we have already discussed. And of course, we have this uniform security model, which applies to all the applications that are managed by Nebulous. Nebulous can manage applications for more than one organization. So you can look at Nebulous like some kind of a super cloud broker platform, if you want. So for the tools for the modeling, we have the ability to express the application topology, so the components and their requirements. We have the service level objectives, and we have the optimization criteria, which is the trade-off that we have to make between performance, location, price of equipment, on price of resources, and this kind of stuff. And we also have developed a specialized semantics so that we can reason about the service level agreements that is offered by each of the providers of resources, hardware resources. Then we have multi-criteria resource brokerage, which is that if someone wants to offer resources to Nebulous so that Nebulous can sort of distribute this to the applications, then these resources will be registered, they will be managed, and if they come from different providers, then Nebulous will ensure that sort of the application will have one contract with Nebulous, and then Nebulous will ensure that the providers of these different devices will be paid according to their required business models. And this is quite complicated in the sense that we need to decide when we make a deployment, we decide on both the sort of the obvious criteria for that resource, but we also look at the previous history of that resource in sense of its ability to deliver according to the SLA promised by the providers. Then we have smart contracts, which is a way to ensure that we have the same view with the providers, and so that we can also penalize or provide benefits back to the providers. So here there will be some kind of a virtual nebulous currency that will enable us to negotiate with providers of resources, and also the cost shared or charged to the applications. The optimization part is per application, so each application will monitor its own resource use, and we will have the possibility to forecast and detect when the application is in need for a reconfiguration. And the hope is that we can do this with a long enough horizon so that the reconfiguration can be in place by the time it is needed by the application. So for instance, if there is seen an increase in the number of users of an application, then you can scale in advance and be ready for offering the reconfigured and better application closer to the user if that is needed on time. Then we also have this AI-driven anomaly detection. So basically, we are building a model. What is the normal operation of the application on this particular node, this particular resource? And then if suddenly this resource has an increase in, say, bandwidth use or CPU use or the RAM use, then we can sort of say that, okay, now there is something strange happening on this particular node. We exclude this from the Kubernetes cluster of the application, and we recreate the component that was running on this node on a different node instead. And all of this is, of course, based on what the user expressed in this modeling tools that I talked about earlier. Then for the security, we have several approaches. We have, first of all, this isolated computing cluster for each application. So each application has its own Kubernetes cluster where we take care of the security of that cluster so that everything happening inside that cluster should stay inside that cluster. We offer secure virtual networking to communicate inside the cluster, but it can also be extended towards the external data sources if there are any one that can be supported by our current VPN technologies. And then we, of course, have a centralized management of who can start applications, who can close applications, and what are the credentials that an organization has towards different providers like cloud providers and this kind of thing, which is not necessarily managed by the nebulous broker system. We have, well, here it is 5 different demonstrators. In reality, we actually have 6 because this fresh food supply, this is basically 2 different applications that are linked and correlated. I will come back to them. So for the renewable energy windmill inspection, we have drones that are inspecting blades of windmills, and if the image detects some kind of surface scratches or other dangerous situations that could happen for a windmill, then this will trigger a secondary inspection. And it's important that this secondary inspection happens as fast as possible while the drone operators and the inspection team is on site on the windmill park, which means that this will be done mostly on sort of a notebook, which is the edge resource for this application, and then used to detect problems immediately. Otherwise, it will be sent to the cloud where there is a severity classification of the problem detected on the blades, if any. A second use case is for the smart cities, where we have intelligent lampposts equipped with quite advanced computing capabilities, at least some of them. And the issue here is that when an issue is detected in the city, whether that is a fire or a dangerous situation or something like that, several of these lampposts could be coordinated and used to figure out what is actually happening now. Several cameras can be pointed in the same direction and automatically give a better overview of the scene, and then eventually trigger to some kind of city managers what is the real issue. So here there is the problem of using different hardware platforms with different capabilities in these platforms, and also scaling out to the edge resources and scale to the cloud if edge is not sufficient for providing a good analytics for the situation. Our agriculture use case is basically a workflow type application where we collect data using a tractor in the field, and these field data will then be uploaded for further processing at different stages. So one is at the edge, first level is at the edge processing, and then the results will be eventually transferred and stored in the cloud. The first of these logistics use cases is about detecting trucks coming into Mercadona in Barcelona, which is an area where you have the wholesale of vegetables and food and other goods that are collected there and then sent out in the city for the different shops that are reselling this to the users or the normal clients, customers. And the idea is that these trucks that are coming in, they can create traffic problems if they all come at the same time, or if they all move towards the same warehouse, etc. So the idea is to direct the traffic inside the Mercadona area by using cameras that can detect the plates of the cars and then or trucks, and then send them the best way to the warehouse where they are either picking up food or delivering food, or so that they are not creating traffic problems inside this area. The second thing is, of course, that this the food and the goods has to be delivered to the shops, and for that we also plan to have a second application which actually follows the trucks that goes out in the city, taking into account the traffic status and the load of the vehicles, and trying to find an optimal route for delivering the goods to the final shops. Then we have a use case on rescue operations, and this is quite interesting because the application is being used when there has been an earthquake or a flood or a major forest fire or something like that, where the idea is that the application is being brought into the area and support the rescue workers and the different rescue teams and the different rescue the layers of the rescue organization in actually providing support to the victims on time, on site. And the problem here is that there is no network. Often there is no network. So after an earthquake, you have to set up your own network to the extent that this is possible, or you have to use other ways of communicating, or maybe you have to accept that in some situations there is not possible to communicate at all, and you have to do uploading of images, coordinates of teams, etc. when you actually get connected again. So this is a sort of the variability in this application is caused by these network issues. So how do we see the research challenges? Well, Nebulous now works on the sort of the virtualized resources from either from private data centers, cloud providers, or edge servers. And over this area, we provide resource brokerage and optimized application management and security. The data spaces is something which is coming and which we are not natively now supporting. And this is definitely something that we need to look into, which is covering the same scope as we are now operating inside. And this will be sort of the first level for inclusion. Now, on the other hand, we also have issues about edge devices that could be mobile. And if you have a mobile device, then handover becomes an issue, because if you move from one base station to another base station, and this second base station is owned by and operated by a different provider than your provider, then your traffic is suddenly being sent to the core network and then back out again to the edge server that you might have had in the previous base station that you were working at. So predicting this kind of movements and these changes in device locations will significantly impact where to place actually processing capacity and storage capacity. Then we have not in Nebulous today any kind of control over the actual networking. So we use the network that is in place between two nodes, whatever that might be, and we try to sort of optimize the location of the computation and the nodes rather than changing the network characteristics. So this is also one issue or one topic where we would like both to collaborate with others. And I saw that Nemo had some very interesting work on software-defined networking and this kind of slicing management. And I think this is the next step for us to try to investigate in that area. And then beyond that, I think that for more Internet of Things swarms related systems, I think what we can do in that direction is moving towards energy management and looking at holistic application management from an energy point of view. So to sum up the roadmap that we have for the future and beyond the Nebulous project is first, probably moving towards data spaces. And here I'm mentioning Simple, which is a big procurement action under the digital program with the aim of developing a middleware for data spaces. And when this becomes available, it's probably something that we would very much like to integrate with to facilitate both dark data markets and federation of data spaces across the Nebulous managed application and domain, and also between applications, so that they can exchange data in a structured and useful way. Then for the networking part, as I said, we have the issues of mobile edge devices and the handover management, but we would also probably like to extend our optimization into the level of software-defined networking, and in order to be able to actually acquire the network's resources or the bandwidth we need between two nodes. And then finally, energy management is something that is coming. We need to look into this. It's extremely important for mobile devices, of course. But before we get into mobile devices, it's also growing importance for this when it comes to AI processing and this kind of heavy processing that requires a lot of resources. And if we can optimize that for energy using the most energy efficient devices for the computation, that will definitely be a direction which we will move in the future. Currently, we have our first open call open, and we aim to acquire about 9 projects in these 2 open calls. So if you are quick, then you can manage to provide an application for the first open call, which closes 17th of April, and where we ask for applications within 4 different domains. Workflow application, which is basically applications where the tasks have a duration, they have an output, they have an input, and this downstream tasks cannot start before upstream tasks have finished their computation, so the data is available. Then we also ask for more IoT applications, which actually demonstrates and has this variability that we want to manage and that we are capable of managing. We want to have examples of serverless applications. We do have some serverless processing already in the project, but we definitely need more, and it would be very interesting to have sort of a large-scale serverless application. And then the last challenge which we have posed is completely open, so you can propose whatever application you think you need in that. So this is basically where to find more of the open call information, and you also have a QR code that you can use to get more information. So this was it. Thank you. Very brief, and I think I was almost on time. So thank you.
Yes, thank you very much here. And thank you to all the speakers for being with us today and representing all the projects. Very interesting information. In case there are any questions, please feel free to reach out through the links and the channels that you saw in the end of each presentation. And of course, follow our social media and stay up to date about all the wonderful opportunities that lie ahead via the open calls. Thank you for joining us today. And yeah, our webinar is over.
Thanks, Alexia.
Bye-bye.
Thank you. Bye-bye. Thank you.
Thank you for organizing, Alexia. Bye to all joining us today.
Thank you.